good day. Today we try to continue what we postponed from previous class. So last time we tried to learn about the example of the uh, refrigeration design. Uh, so we touched about one of the design, maybe touch about the cold room. So one of the group already declare they may be focused on the cold room design. So today I would like to touch about the trouble shooting in the cold room. So we will cover about the maintenance, how you cover your maintenance. So today I will touch about that. So firstly, before we go to the troubleshooting, so maybe we understand first what the cold room will be served in the field of the refrigeration systems. So maybe cold room will be cover about the food preservation. Preservation mean that the refrigeration is the most widely used mean in preserving food in its original fresh state. So refrigeration involves the use of the low temperature as a mean of the preservation of the perishable by eliminating or retarding the activity of the spoilage agent. And the degree of the temperature required to adequately preserve various fruits, vegetable, and meats varies with the length of the time the product is to be stored. So as we know, maybe this cold room will be dominant by like uh, grocery store, and then the grocery department, and then maybe convenience store. Some of the convenience store also keep the or store the food like the uh, ice cream, and then also some several of the listed uh, carbonate drink, and then also with the like um, milk on the also maybe in the like the vegetable or fruit. Okay, as we seen in the slide there, some convenience store also provide with the frozen food, like a pizza, and also nugget, and so on. So we will serve in several level of the temperature. So maybe the serving of temperature is around negative 35 degrees Celsius until to the 15 degrees Celsius. So this condition sometimes maybe we need to the maintenance because of the, as we know, the this cold room will be experienced in the frozen or froze condition inside of the cold room. So we need to drain it, and then as we know, manageable of the food itself, we need to get the well managed inside of the cold room. As we see in the slide, we need to have a well in the managed, like have provided by rack to manage the condition of the uh, food inside of the cool room. And then you should understand how to the cool room utilize, because some may be only small space, and then we need to manage with good manageable of the thing inside. So maybe we can provide the rack, special rack, yeah, to the inside of the cold room. So maybe some cold room will be served for mobile condition, like in container, or a food truck. But in the that condition, maybe special design needed to cover or counter the uh, heavy duty activities, because this one is really implement in the mobile condition, but no issues when the implement in the convenience store, because this one is already fixed, already there inside of the store. So they have several uh, list refrigerant in the market. So you should be understand the characteristic every of performance, of refrigerant, and every refrigerant also carry of the issues of in term of safety. So mean you understand the characteristic, the refrigerant, and then you understand how to counter of the safety issues. Yeah. So for example, we have here is a CFC, yeah, and has CFC, has FC, PFC, HC, and then terol like carbon dioxide and ammonia. So before that, we already understand each of refrigerant will be bring together with the uh, issues of the safety, yeah, and then classify of the refrigerant itself. We separate by lower toxicity and high toxicity, and also lower flammable and high flammable. Okay. Okay, this one is a characteristic. How to measure the pressure, yeah, of refrigerant. So understand if pressure low, what happen, and then if over pressure also what happen. Yeah. So you need to understand about the measurement of the pressure. Okay, this one is a characteristic every refrigerant in the pressure. So actually, when we operate the refrigerator, we need operate two phases, yeah, within the liquid until the vapor condition. So this characteristic will be different every of refrigerant. So you can see in the list, yeah, the characteristic of temperature based on the pressure. Okay, this how to use the manifold of the pressure. You should be see directly to ice check. So what happen when you see is by the angle, so we will be influenced in the reading of pressure. Yeah, this one is temperature uh, uh, tool to reading the rate of the temperature. Okay, as we know, the basic of the refrigerator, yeah, should we have several components there, like compressor, evaporator, expansion valve, and also condenser. Yeah, and then with add on of the several part that because of the invention, yeah, to make have a good performance in the refrigerator system. So if you serve for the convenience store, so should be well designed in the uh, piping system to serve of the temperature to until to the cold room. This one is other component of the refrigerator. We call evaporator pressure regulator. Okay, you can see one you design of the refrigerator in the grocery store, so you need to design every cold room, different temperature serving. So a slide shown, we have several conditions here. So maybe for meat, different temperature serving, and also for vegetable and fruit will different with the meat serving temperature serving. So you need this one is small design, compared to previous one. So maybe only one air cooler condenser needed, and then also serving by several compressor with different varied condition of temperatures. This is the design, and then we go to the main topic of this week. So we touch about the troubleshooting during serving and maintenance of the refrigerator. So troubleshooting is often referred to as the analysis of the problem. This analysis is generally guided by chart provided by manufacturer of the equipment. So every equipment will be together attached by the guided of the from the company. So if we serve, we this our design is provide the compressor from the company A, mean that you should be bring together with the uh, guided maintenance sheet, anything characteristic from the that company. So the maintenance, and then how to serving, so you refer to the company A. And then for location without the use instrument, so mean that if you missing in the safety issues during maintenance, as mentioned before, you need maybe to protect your eyes, ear, or maybe your mask. Need to protect your what we call in the smell, something, to protect, and then also maybe for your body, other body like the glove, and then the helmet maybe needed, and then if you something feels first symptom, something happen wrong when during operation, you can understand, and then what you do to counter to troubleshooting. Uh, and then observe directly with the sense. Those that can only be detected by instrument. So if this condition is need a special tool to detect the trouble, so mean that you have ready the tool, in your operation. So this one is a symptom that mean you need to reading if something happen in the operation, during operation, if the suction pressure is increase, liquid pressure increase, also increase, and the superheated is low, as supercooling is heat increase, and the ampere also ampere meter is also reading increase, mean that the RH control is poor. So you can refer this condition, you can use this table to describe the condition, yeah, of your refrigerator system. So you can refer this table. This table is very good to guide you to describe what the actual condition. So mean that if you're in efficient compressor, so the reading suction pressure is increased and then liquid pressure lower, and then superheated is increased, and then subcooling increased, ampere meter so is lower, mean that the inefficient compressor actually already occur in the system. So better you can use this to refer to guide you to describe the refrigerator system. And then in the theoretical, you should be understand, because all operation will be referred to the psychometric chart. So psychometric chart is to describe the refrigeration operation system. So the location of the all form fault on even relatively simple refrigeration system is conditional on true knowledge of such factor, to build up of all component, their mode of operation and characteristic. So the operation is referred to the theoretical factor. Okay, troubleshooting guide. So you can use this information to guide you. Yeah, if something happen, so like if you measure the condition of the refrigeration, yeah, by the pressure, yeah, by the temperature, so it will guide you to solve the problem, how to fix it. Yeah. Okay, this one one example. If we have temperature of air evaporator inlet is 20 degrees Celsius, and then the temperature of the air, the evaporator outlet is 15 degrees Celsius, and the evaporation temperature reading on the LP gauge is on the 4 degrees Celsius on the 4.6 bar. So you need to describe this condition. So in the example above, the air if the evaporator at the temperature 22 degrees Celsius and is equal to 15 degrees Celsius, yeah, and give up heat to the refrigeration. So delta theta for the air is around 7 degrees Celsius. Yeah. In addition, the evaporation is 4.6 bar as measured before, and then equivalent evaporation temperature is 4 degrees Celsius. So the theta data total is just differentiate between 22 to 4 degrees Celsius, and then we can get the total remain is 18 degrees Celsius. It's difficult to state the normal values of the theta data for an evaporator because of the problem associated with the theta negative of humidification. So in air condition and with icing and commercial refrigeration. So this differentiate is because of humidification. So another way to increase the performance of the refrigerator, we can use the subcooling. So what is that, the subcooling? If you mention in the psychometric charge, yeah, so mean that after the cooling, we have other step, we have the stage, yeah, to cooling again. So mean that below on the saturated, yeah, cooling system. So if you see the graph plotting within the pressure and enthalpy, you can see the point 4, yeah, point 4 already in the saturated, yeah, mean that they're already in the phase liquid. Mean you need to subcooling, yeah, to reduce the the temperature. Mean that almost to the uh, freezing, yeah, but still in the liquid, but already more to the freezing. So from this condition, the COP will be increased, yeah, because the differentiate within the 0.4 prime, yeah, to the 1 is already higher. So mean that we can get the good of performance. Yeah, so we need to subcooling. So how we need to subcooling, and then we can use add-on of the one device, yeah, to make the subcooling system. So you can see the slide, the what we can do to make the subcooling, yeah. So you can add on the system by this method. And then from the graph also change, yeah. And then another way we can make the superheated to cross to become steam, yeah. So mean that the differentiate within the cooling, subcooling with the superheated become the higher. So differentiate this, then the COP become increase. Okay. Then we can add on maybe to increase the temperature to become the superheated, yeah. And then after that we can get the high performance of the refrigeration. Yeah. Okay. That how to make the troubleshooter. So in maintenance. So that's all for today. I hope you can understand what I want to deliver for your attendance. So I will make the task, yeah, in the you learn. So you answer the question from the task, and then I will consider your attended class. Thank you. That's all for today. Assalamualaikum and good day.